trust model that they're following is kind of like PGP's. Other developers can sign other developers' keys. Hopefully you trust one of them, they trust somebody else that they met, and you will then install their package and trust that it comes from the correct source and hopefully be tampered with. By default, this is not the way that gems work. And in fact, right now there's not very many gems that I've noticed that actually include, that are actually signed. A major exception to this is probably Mongrel, which is a very popular web server for Rails, and that is signed. To install the gem and want to be able to actually check its signature, we'd have to include an extra flag here for high security as we're doing it. And this will make sure the gem is signed, to assert that we trust, and that it's also valid. There's a couple of other different security levels that you can actually do with gems. All the rest of them have fairly easy ways to bypass them. So if you're going to be doing this, you're probably going to want to choose the high security method. But like I said, not a whole lot of gems are signed just yet. So if you made this your policy, you're probably going to be limiting the block. The thing that gems will do is actually it'll keep, if, for example, when Rails had to upgrade from 1.14 to 1.16, and you ran that first gems command to actually go out, grab the latest Rails package and install it on your system, it'll keep the older version of Rails on there as well, and just give you a new directory with the new version on it. So this is really nice if you're upgrading packages and you don't want to break developers' functionality because they're relying on a certain version of a package. Is now that you've upgraded gems on your base system, you actually have to do an extra step now to tell your applications to use this updated package. And Rails applications will kind of work on two ways with gems. They call it either floating on gems, where there's a configuration file where you tell your Rails application what version of these gems to use. So just a text-based file, you can pop that open, upgrade that version number to the latest one that you downloaded, or you can do something where you bind yourself to the gems. And basically, there's this write command that comes with Rails as well. You can freeze all the gems that your application is currently using into a subdirectory of your Rails framework. And so basically, it'll lock it there. People can install whatever they want to the base system, but your application will always use the same gems. So you have to remember to re-rake that then if you have an upgraded package that you need to be using. This is very handy then too. You have all the gems you need in one directory in your application package. If you need to distribute it out to multiple servers, this kind of freezing thing is very popular for doing that. Now I mentioned, that first command that we saw, we created a bunch of files and a bunch of directories on our systems. So it kind of depends on what operating system you're using on here, but you want to go back and actually check those default permissions on those directories and files that are created. Typically what you'll find is that there's a config.database file in the directory that's readable to everybody. That contains your username and password for your database. So anybody else that has access to your system would be able to read that file and see your database username and password. So that's probably one of the files you want to go ahead and lock down, as well as your log files. By default, they're going to be readable and writable to everybody. So take a second to actually configure those and lock those down as well so people don't start manipulating your logs. One of the things that I see very commonly in a lot of sort of the Ruby, as well as just kind of creating all those directories for us right off the beginning. One of the things that it's nicely done is it creates a little script and it has its own sort of built-in database, built-in web server, and you can configure this to a different one if you wanted to. Basically, what you see a lot of times in documentation is, here's the way to start up your web server, here's the way to start up your Rails-based application. It's called Ruby scripts, blah, and it'll fire up here. The default port it's going to run on is 3000. So if you're going around internally scanning for new web servers on internals, add 3000 to your list of ports to look for. And basically, at this point, we're going to have our Rails application running on there. But a lot of times, this is all that you kind of see in the documentation for how to start up your web server, how to start up your Rails server. And anybody that's been working with Apache or other frameworks for a while knows that you don't want to be running your web server as root or as a privileged user on your system. So you want to make sure that you actually go ahead and either use a sudo command or change your configuration script so you actually start up as an unprivileged user, a nobody, or a www account, something like that. You're going to bomb out and break right away because it's going to want to try to write any of your session information to this temp/sessions directory. And if you're now running as an unprivileged user, you won't have permissions to actually write to that directory. You're going to have to go in and change the permissions on there. I've seen some people that actually schmotted these to 777 so everybody can read and write session information for anybody else that's using the application that they have access to the. That's a bad idea. We'll talk a little bit more about the different ways you can actually store your session information. But right now with version 1.1, 1.2 of Rails, it's actually going to be writing this to disk, your session information in between states. It's not going to just save it to memory. It's one change in your configuration file that you can make. Tell it to actually just keep these session data in memory or write it to the database instead of disk. But this is kind of the current default way of doing it. I'll talk about the next version here in a second. But Rails and sessions, they really don't have a good built-in way of expiring sessions at this point. And security consultants, that's one of the things we talk about over and over again. So you don't want your sessions being out there, being open forever. So especially think about these files being written there to disk. Rails developers have had stories all the time about too many session files being written into this directory. And in fact, at times just kind of completely knocking down the server because they've written 300 million or so different of these files into a certain directory. They can't LS it, they can't delete them, and so forth. So there's been a move away from kind of writing these to the actual file system. But this idea that they don't actually expire by themselves, you're going to have to write some code in there to actually go through and clean up that directory. I've seen a lot of scripts kind of online of people that write little chunks of Ruby code, and then there's a cron job that runs every day to clean out that directory. There's also GEMS packages that you can install with your application and use that to actually expire cookies in a timely manner. So there are ways around it, but by default, it doesn't have a really good built-in session expiration. Now, with Rails 2.0, that's going to be coming out sometime soon now. The release candidate 1 was put out earlier this month. The default way of storing cookies is going to go from putting it on your local server's file system to actually pushing them down to a client-side cookie. So if you think of that, we now have our server-side session information going to be sent down to the client side that they can view. It's just going to be encoded. It's not encrypted. There will be a hash associated with it, so that when sent back to the server, it's going to have to make sure that that hash matches before it loads those values into memory and actually uses those. Again, there's not going to be built-in expiration. Somebody's going to clear their cookies, or you're going to change your secret password on the server, and that's going to expire these. But otherwise, there's no built-in expiration. The cookie that's also your session will be valid until either of those two things changes. And this also makes it definitely possible to brute force these cookies in an offline manner. So here's basically what it's going to look like at this point. You'll have your application name underscore session for the name of the cookie, followed by a huge long text string. So this is going to be the base64 encoding, URL encoding of your session information that's been dumped down from a serialized object. Be two little dashes followed by here's your hash down here at the end. And basically right now, this hash, by default, is going to use SHA-1. You are able to configure it and tell it to use a stronger hashing algorithm if you'd like. But the default will be SHA-1. And it'll add a server-side secret password to that hash to make sure that somebody doesn't tamper with it. It's completely up to the developer to set that password to whatever they want. Yes?
Is that password site-specific or session-specific, or?
There's no, it's not tied to any sort of session information. It will be tied to the application. I believe it's the environmental.rb file.
Okay.
So each of your applications hopefully has its own unique password to it. But you bring up a good point there. You crack it for your own cookie, it's crackable if that same password is the same password everybody else is using. And in fact, at this point, this is your session information. This is things that people, when I typically write in an application before, things I was storing in the session was, your user ID. Are you an admin, a true-false sort of field? What groups do you have permissions to view in the data in the back end? If I have a cookie and I'm able to write to that and see the information that's already in there, I don't really care about stealing somebody else's so much. I mean, I can probably just go ahead and start tampering with that and changing my interaction with that application in very severe ways up there. So this will be interesting to see what happens when this rolls out. Most of the actual Rails developers I talk to are not using this method to store their sessions. But it'll be interesting to see once this is the default, how many people actually do use it. So as we're talking about sessions here in general sort of Rails security, this is for Rowhead in the back here. Session fixation attacks. Rails has finally patched this now with version 1.24. It no longer allows session IDs by default in the URLs, but this was just released in October of this year. So you're probably going to find a lot of Rails applications that are still going to be vulnerable to session fixation attacks. And it's one change in your configuration file. You can turn that back on, but it's nice to see that by default that's going to be off now for Rails applications. So let's talk about some of the really cool good stuff that Rails is doing security-wise. And to start off with, how about SQL injection? One of everybody's favorites, been around for a long time. One of the great things about Rails that developers I hear really loves is this active record object. And basically it makes interaction with your database very easy and very simple. And already has built in a lot of the functionality you're going to want for your standard web application interacting with your database. So my example earlier, we kind of had the users table. We just created a database called scaffolding or users object for us in our code to reference and call standard SQL queries to, such as find or create or add, simply by passing in, pretty typical standard values. You want to find an ID for a book, or you want to create a new record based off all the parameters that are passed into us. So the typical convention way of actually doing these in Rails protects you pretty much from SQL injection. It treats all these as somebody who's properly following that Rails convention. It's not to say you can go outside of the convention and still do it wrong. It is possible, but you're probably going to see less of that here in Rails applications versus other frameworks. And I was kind of curious, okay, well, does all this, it kind of has this magic that it'll map my columns to these objects, know how to insert things. What happens if I try to put too much data into one of these fields here? As an attacker, try to get more information out of it? Well, Rails knows how large you've created each one of these columns in your database. It'll automatically truncate the data to that specific length if you try to put too much into it. It'll do that silently. So if you as a developer actually want to have a check to let somebody know they're trying to insert too much data into your database and you're going to truncate it, you can actually write some very simple validators to check and look for that information. The next topic I want to bring up is that Rails does have a lot of built-in validators already for developers to use and start looking for this data. So things by default that it already comes with, it's got a check for length, a check to make sure that data has actually been filled in for any sort of object. The format field I'll talk about a little bit more. Make sure it's going to be unique if it's going to be inserted into a database table. So a nice default set of these validators, and in fact people can kind of write their own and use these validators over and over again between their applications. So it's a very nice way to kind of build up a good set of validators and reuse them throughout your whole life cycle. So common things you'll see again, that kind of phone number, just make sure the data's actually been filled in and checks. Format allows you to kind of do some regular expressions, so we can start kind of building up a whitelist and making sure data being entered matches what we want. And of course, it can get pretty complex down here at the end here where you see this long regular expression. That might be a good over and over again. Let me write a validates underscore URL of a validator. I'll just make a simple call over to that next time I want to make sure somebody's passing in a valid URL to me. So a lot of validators kind of built in for people to kind of handle that input validation, but still nothing here that's going to stop you from doing logic flaws within your app. So this is, you see a lot of Rails shopping carts at the moment, and this old sort of web attack. All right, so there was a whole talk yesterday on cross-site request forgeries that was really interesting, and it's been 45 minutes. I just have one slide on it. Next version of Rails, CFRF killer plugin. It's going to have a token associated with any sort of get put or delete request that comes across. I'll talk about those more later. But basically, this is going to be on by default. It's going to be on for any. Your problem's probably solved right there. Especially when we see how Rails kind of interacts with GET requests. It's not going to be typical for a Rails application really to be doing sensitive data transversed over GET requests like we sometimes see with other frameworks. And for earlier versions of Rails, it's a gem plugin. Go ahead and install it, turn it on, you're good to go.
Sorry, I have one question.
Mm-hmm.
So if you're expecting a put instead of a get in a Ruby app, and I make it a get.
Your application, but typically yes. Okay. And there's a big push in the Rails community for going for RESTful applications. So that would definitely clearly have an effect if anybody's developed their application that way. Okay. So, campus security, talked about a little bit of buffer overflow, and I kind of agree with Jeremiah Roseman's take that we really don't. This is from the Owasp webpage on buffer overflows. Ruby in there, it's an interpreted language. It's strongly typed, no direct memory access. Your chances of actually writing code for buffer overflows is pretty slim. That being said, it is still possible. There could be a buffer overflow in the Ruby interpreter, just like there was one found in Java earlier. I believe it was earlier this year. But that could have a huge effect if that's the case. A Ruby developer could actually install a gems package to do what's called Ruby inline and write C code directly within the Ruby files. And of course, if you're writing C code, then you can have buffer overflows as well. So it's possible, but it's fairly unlikely. All right, so how about cross-site scripting? A number of the original sort of early Rails books that I was looking at and websites kind of played off cross-site scripting as just being something that's going to affect people trying to steal sessions. Doesn't make much use of sessions. They kind of told their developers not to worry about it. Obviously, anybody that's probably here at this conference knows that that's not the case anymore. This is something you have to worry about for whatever your application does. And actually, Rails makes it very easy to actually protect against, or actually to do HTML escaping. It's simply one letter that you have to add, just an H out there, and your data is going to be HTML encoded for writing back out. But of course, having developers remember to actually put this on every time they're writing out data to the page, you can probably see some areas where they might have problems and slippages actually remembering to put this on there. So how about somebody wrote a nice sort of Rails plugin for that, Ruby plugin for it called SaveERB. Basically, this almost works as sort of a reverse taint. It's going to check everything that you're writing back out to the page and make sure that it's either been checked or escaped beforehand. If it hasn't been, it just crashes. Won't display anything to the user, creates an error message on the server side there for you. Ruby also does have a built-in $safe that works similar to Perl's strict or taint command in there. But again, that's more for input validation instead of where this plugin's kind of doing the output validation, making sure you're checking your output before you write it. So it's not recommended to use safe. In fact, it'll probably cause your Rails application to bomb out. But that's recommended instead. In terms of output validation and checking, I did want to have a little weak sauce alert here about one of these plugins for it. Text Helper has a sanitize module that's been written that's kind of people will, if you want to include some HTML, but make sure people don't have code in there that's going to affect cross-site scripting, run it through the sanitize method, and it'll do things like this. Remove any of your form or script tags, remove all on whatever sort of attributes, make sure nothing starts with JavaScript : but this is all done with a blacklist. And if you take a look at kind of these examples down here and ever saw RSnake's cheat sheet, probably take you all about 5 seconds to come up with ways to evade this filter. So I would not recommend using this for your cross-site scripting protection at this point. It will be moving to a whitelist when Rails 2.0 comes out, but I would still recommend the SaveERB. Weaker checks sort of levels. A lot of the documentation I've seen that talked about, hey, developers, you can check and make sure your request actually came in from an AJAX request and not somebody directly hitting your page. It's got this little request, XHDR ? Check that you can do in your code, just kind of make sure that it's coming in from that request. All it's doing is adding an HTTP request header going across. If you're doing your testing, you're running Peros or any other sort of proxy, you're going to see this header come across. Just make sure to include it with your request, and you get around a simple check like that. Okay, so now kind of a little bit more fun type of attack here. I keep talking about how Rails will kind of figure out, create one table and it figures out what you want to do with it, creates an object. allows you to easily interact with it. It's all cool and great, and there's this create new methods for these objects that passing in parameters are getting with the form, and it'll know exactly how to create that new record in the database for you. Well, where this could be a problem is if you have a table such as your users table, where you're going to have common things split between regular level users in there, regular level records, and then maybe administrator accounts in there. You may have an additional sort of column in there that is admin flag. Maybe you're going to have a little improved flag there to make sure, hey, is your email address valid? Did you click back on for each one afterwards? So when somebody's initially maybe signing up externally on your site and you just allow them to fill in the username and password part of this table, if you got your form request coming to your site, you're probably just going to have maybe two parameters like this for the username and password. Rails will put that into its user.create or user.new object, and it will create that record for you. Well, what you can sometimes do then is if you database, you can add those additional fields, additional column names, and any value you want along with your request and send that in. And if those columns exist in the database and you're supplying the correct data type, it'll actually go ahead and create that record with those additional features, additional options set in there. So again, this is something where as an outside tester, security tester, if you're looking for ways ways Rails can kind of help you with that is the URLs we were talking about before are tried to be pretty readable. So you usually see something like /users or other things that kind of give you the actual names of database tables. If you look at your HTML form that comes back, typically you will actually see the column names listed in there as the form objects. It's not like other languages where sometimes the HTML guys do things differently. It's going to be usually pretty closely coupled. And so guessing those additional columns is probably going to be a lot easier for Rails-based applications. And you mentioned earlier, if they're using those Rails 2.0 session cookies, look through that session information, and maybe you'll see some of these actually added into there as well. It's very simple to actually protect against this. One line of Ruby code after you've created your database. You either have a blacklist approach or a whitelist approach, and just basically tell your Rails application, okay, these columns should be protected when they come in from this form, or you can say, okay, this form the object is allowed to write to these columns here in my database. So obviously we recommend the whitelist in case you go back later and want to add a column to your database. You don't have to remember to update it in your code as well. But that's something you want to do if you're using any tables in that sort of way. In terms of response splitting, I know a lot of security consultants I talk to kind of write off response splitting as being very theoretical attack, very hard to this right network connection, latency, and everything else. Well, one of the things that, because Rails is single-threaded, you find a lot of times that there's going to be a reverse HTTP proxy present on the server side in their architecture there. So in terms of response splitting attacks, here you now have a larger target audience of, if you're able to actually poison that cache, you're going to affect everybody who comes and views this Rails application. It's not going to This is going to go ahead and poison everybody that's coming to this Rails application. So definitely check for response splitting. I commonly see this in the file names, the cookies, any sorts of redirects. So check for this if you're looking at Rails applications. What's kind of coming up in Rails 2.0? I've already kind of mentioned some of these things. On their website, they've listed these features as kind of being their security changes. The protect the sanitize method moving to the whitelist. They'll have support for HTTP-only cookies now. Anybody that is actually checking for that. And then the default sessions is going to be changed. I added that one to the list. But where the whole Rails community is kind of making this drive to, making this push to, is kind of going to RESTful interfaces. In 2.0, the web services component to Rails is actually going to be pulled out and put into its own gem. So you can still do web services with Rails. It's going to be an extra gem to add in. They're making a push more to kind of have this RESTful interface for it. So when we're used to kind of, as security consultants, I'm used to seeing all the time getting post requests. And we basically will tell people you want to lock down your server only to allow these HTTP methods to come across. you start seeing deletes and traces and everything else going across. It's like, oh, you know, you want to lock down your server a little bit more. It's going to be interesting as and trying to actually make use of these additional methods, which are there, part of the RFC for HTTP 1.1, and make use of these. So if you see a put request going across here, we know it's going to be so we can update an object. So for example, down here, you know, we try to make the URLs very readable. If we want to update product 3 in the database, you know, instead of having additional parameters down here that would either specify what table or the unique ID of the down here, but maybe it's, you know, you're not quite sure what you're going to want to do that for. It's going to really be dependent based off of these methods going across. So if it sees a put, it's going to try to do an update. If it sees a delete here instead with that URL, it's going to try to delete that object in your database, that column in your database. So this is kind of a different way of interacting with web applications than I think a lot of people are kind of used to dealing with. Big push that the Rails community wants to kind of go towards. It's been available in Rails for a while. I haven't really met very many people that are using it just yet, but it'll be interesting to see if this is the actual direction it goes in the future. And if you're looking for more information on sort of Rails security, Owasp, their last summer of code, put together a pretty nice PDF of the Owasp top 10 and how it applies to Rails. So that PDF is available off the site. It's a little for it. The same guy, Hiko, has also started up this Ruby on Rails security.info site where he kind of blogs about any sort of security concerns that come out in Rails. So that's a good resource as well. Alex Holman over at Foundstone, if you want to kind of quickly play with a Rails-based application that's full of some of these holes that I talked about here really quickly in the slides and try it out on your own, here's a way you can actually download application allows you to actually go through it and test these out and see these flaws in a Rails-based application. And if you're kind of looking to stay up to date with what's going on in Rails and some of these new features, the Rails log is really a good resource, and I keep going back to that